Okay, let's resume the class. In previous class, we talked about many types of manufacturing system. For that aspect, we take the example of Sharp ENG and Bechtel and Hyundai Motors and Samsung Electronics and ExxonMobil. These factories has their own type of one of its characteristic type of product, which can be used as the typical example of the product, which defines the production system. Okay, and in my lecture number 1, we talked about the shipbuilding system, how shipyards produce ships and offshore structures. So I assume that we are now familiar with how these ships are produced. So my question number 1 at the very end of the previous class was this. How would a ship production system compare to the systems discussed so far? And the answer and the discussion was it's very similar to construction engineering, right? Compared to the number of compared to other manufacturing system with respect to the number of product per product design and number of intermediate product and number of what? The similarity between intermediate product as well as within the product and product mobility, the revenue from one single product design and many other aspects. Okay, let's discuss this one a little bit further. We began to discuss of the influence of these key characteristics. Number of units from a single product design. Okay, delivery time required to meet demands, and expected revenue, earning money from a single product design, and degree of similarity between product, degree of product mobility. Okay. Also, number of part or intermediate products per unit, degree of intermediate product similarity, both within and between product design, and intermediate product flow to final product. Okay. These are influencing the characteristic of manufacturing system. Also, how this intermediate product, the part, flow to the final product. It does also influence the manufacturing system's characteristic. Similarity of product structure between products. How do you think this one influences the flow? Well, if there is a high similarity of part within the same intermediate product, it is kind of natural choice. You put this thing into one single product line to, increase the efficiency of the production, right? If the similarity is very low, there is no way to integrate these two different product lines into one. How about the number of levels in a typical product structure? Well, if you have to only assemble a couple of times, then what? Think of the assembly. You need number of different parts first to assemble them together, right? The assembly means yes. If this is to the final product, assembly means the merge of intermediate product flow, right? And breadth of product breakdown structure means the number of different parts. If the structure is wide, which means you have lots of parts together to assemble. Okay? How about level from which final products share identical and standard intermediate product? Well, let's think of it like this way. Grand block level, assembly level, sub-assembly level. If the level from each final product share identical standard intermediate product is really low, then all the above level, everything will be identical, right? Which is very good, right? Okay, think of that. Okay, I need to clarify one more thing. First one is the intermediate product. In another word, it's a part. Any constituent physical or informational portion of a final product that objectifies a discrete set of production work. So, is raw material intermediate product? Is raw material intermediate product? Anyone? Yes, right. Is a part intermediate product? Yes, of course. What else? Intermediate product. In shipyard, outfitting is really important. It's very complex. Outfitting takes place zone by zone. Once a ship is completed, right? It's a huge building floating on the water, and the spaces are divided by different outfitting teams. Some teams are responsible for outfitting one big space. For example, let's say there is three huge, large cargo tank for a LNG carrier. This one huge cargo tank is one outfitting zone. And some teams are supposed to go in there to put the insulation, or other things, required things. In that aspect, is a space intermediate product? Yes. Sometimes a zone can be an intermediate product. Because of that, outfitting zone could be a part of product structure. Okay? Because it's that important. Sometimes it is more natural to consider this outfitting zone as a work. And there is some confusion between work or product out of this outfitting zone. So, based on many other discussions based on that, somebody invented something called product-oriented work breakdown structure. Okay? Anyway, I will cover it later. First one, let's talk about this product structure. Okay, it's a graphical representation of how raw material, purchased component, intermediate product related to one another hierarchically to form a final product. It's very simple. Let's say this is your final product and your product would be represented like that. Okay? If this and this are assembled together to make this, And once again, this and this are assembled together to make this, and etc. etc. This is the product structure. Nodes represent individual raw material, or except this root. This one is final product. Other than that, all things are intermediate product. This one could be a raw material or purchased material and the like, but anyway, all these nodes means intermediate product. And the line which connect these nodes means the relationship between this intermediate product. Generally, in the yard, they call BOM, bills of material. In English word, bill means what? Bill. In Korean, 영수증, 명세서, something like that. 명세서, right? Material, 재료, 재료 명세서, which means what kind of raw material or what kind of intermediate product or purchased product are required or inside in your final product. This is a bill of material, which are like this. So, I don't think I need any more explanation. This is very straightforward. Some are assembled together to actually eventually make a product as a final product. This is the bill of material, right? And sometimes it is and sometimes it isn't, but usually this vertical location, for example, B, C, D, E are at the same location vertically, and this vertical location means the level of the product. So sometimes in shipyard, if A is a ship, B, C, D, E level means grand blocks, and F, G, H level means sub block or something like that. Okay. The other thing is work breakdown structure. Structural representation of the work or task, work task, activities. It is not physical thing. It's a process, work, task, things to do, associated with the production of product or products. Okay? So it's a kind of mirror image of your product breakdown structure. You know, in order to make a product, you have to do something. You have to put some working into that. Those working is also interrelated to each other hierarchically. So that means this one is also represented as a tree structure. So people call this work breakdown structure. So it's often represented as a hierarchical outline of work from general to specific. Okay? For example, in order to make some assembly, you have to cut some part from the flat plate first and have to align it and weld something together, finally make that sub-assembly. So build block 101 actually includes many other subtasks: cutting, material handling, aligning, joining, something like that, which can be make also this breakdown structure. Okay? Can you see the arrow, red arrow? These are connected like that and that. So, at the very right end, this is a assemble task, assemble block 101. In order to do that, this one means sub-assembled stiffened curved panel block 101. And you have to have many other things to make this block 101. But anyway, this sub-assemble stiffened curved panel sub-assembly requires two things. Shape plate part. Shape means bending or, forming, not cutting. Okay? Okay, shape profile part. Shape plate part means from a, flat plate, you have to bend it like that. That is a shape. Shape is verb. And if you want to put the stiffeners on top of it, you have to also bend the stiffeners, right? Right? So shape profile part here. Cut plate part, you have to cut before shape it. Cut profile part, you have to cut it before you shape it. So this is the simple example of work breakdown structure. Okay, it's a one example of sometimes we call it a Gantt chart. It's a very famous. Is this correct? I don't know. Isn't there any D inside of it? Anyway, people call it Gantt chart, and it's a very small to hard to see, but anyway, you can see there is a bold task name and some indentation and other task name. These are the subtasks of that. Okay? The three are subtasks of the first one, and these 1, 2, 3, 4, 5, 6 are also subtasks of this number 2, and there are many other subtasks to that this first subtask. So it's hierarchically arranged, and on the right side of that task name there is a starting date, ending date, and the time duration required. And based on that time duration required, the bar length are determined. Also, there is one more information. In order to do some task should be done or should be completed first, beforehand. Those precedence information is also in each of these tasks, so which determines the arrows connection. Okay, based on that, they do the scheduling. It's the very basic project management. It's one simple other example of how this work breakdown is working. Alright, okay. My question number 2. What kind of production process fits commercial shipbuilding, and what's the reason for that? Any other ideas? Okay, let's revisit these key differences of since we said that our ship production system, offshore system production system, is very similar to construction, but mass production is really famous, and nobody can argue that if you're gonna produce many identical parts, mass production is the answer, right? But what's the key difference? Well, let's see. Production volume and rate. Okay? Mass production, you're producing really many identical things. But construction, 1 or 2, mobility of product. Can you imagine that mass production system which can produce non-mobile product? No, right? You know, apartments are identical. Each unit are identical, right? What do you think? Is this mass production system? Okay, any other? You cannot move your final product. It should be there. So, if you are building an apartment here, then you need your factory there. Because the product cannot move, factory should move to that site, right? Manufacturing system should move to that site. So, many people call this construction as a site engineering. Everything should be done at that place. Okay, once your apartment is completed here, and you need another exactly same apartment right beside of it, what should you do? You have to move your factory there. Okay, is this factory same as this factory? System-wise, same. Location-wise, it's a different factory. Okay, that's one thing. The other thing to consider, in the same apartment building, you're building the first floor and second, third, and the like, right? Since even though from the top view, the factory which actually built the apartment is right there, but vertically the location is constantly changing. You're producing first floor there, and then second time you're producing second floor on top of the first floor. The place where the manufacturing process takes place is different. Okay? Your factory, workstation, manufacturing processes are moving because your final product, some floor, cannot move anywhere. Okay? I just like to say that there's one very interesting example. In old days, I don't know, it is true also in apartment building. In old days, Daewoo, heavy industry, are the name of Daewoo Shipyard, right? Nowadays, their name is Daewoo Shipbuilding and Marine Engineering. And when their name was Daewoo Heavy Industry, some of their branches are actually building the apartment, and they are active players in the construction. And one of their idea, I saw it in their building convention, is block construction. This is a field of site, and they are supposed to build an apartment building like that. And their key idea was building a factory there. So they mass produce a one-floor unit, which is identical. And their plan is lift the whole thing with a heavy crane and put here. First floor is done, and build it the second floor right here and put that here. It's exactly like a shipbuilding. I'm not sure they are actually using this kind of method or not. If this is the case, then I can agree with you, this is mass production. But, do you think it's possible? Why not? What? Heavy?
They have now the structure
Because of the weight? No, lifting or something like that. Okay, let me re-explain it. They have some special fixture which can grab it nicely one floor of this apartment building and one huge crane. So it sounds like feasible anyway, and you know, all this piping and electronic lines and all other things can be taken care of because in shipbuilding we are doing it every day, right? No problem at all. But I think, you know, something, you know, the material is reinforced concrete and all this, you know, the steel structure should be welded together and then this concrete should be cured. Those kind of joining was a problem in my eyes, you know. If everything is a steel structure, then no problem at all. We can just weld it together. But things is a real problem. And one very nice thing to say is, you know, in our department, we have Professor Bergan, who teaches the Ocean Systems Innovation, who majors in civil engineering, okay, has many experience in this field. And one of his key ideas is to using concrete to build a ship. You know, have you ever heard one of his seminar about the steel sandwiched concrete? Okay. Key idea is like that. This is a thin steel plate, stiffened like that, right? And put concrete here and cure it. It's a sandwich structure. And he once distributed the sample concrete material, and it's really light. And he said it could float on the water because it's so light. So if you put those kind of very special concrete within these two steel plate, then you can make a really rigid flat plate, and you can actually reduce a lot of time. For example, we are utilizing steel plate, but it's not that steep. In order to increase the steep, we have to put the stiffeners. Because of that reason, the ship structure is very complex. But if you use this kind of prefabricated plate, it is just stiff enough, so you don't need any web or stiffeners at all, which can greatly reduce the work required to put the stiffeners and webs and welding and other things. That was his idea in his seminar, so I raised a hand. You have two big problems. First one is, how can you inspect the cracks within these two steel plates? Well, have to think about it later. And second thing is, what's the curing time required to put this plate together? He said about 3 to 1 week is required. I answered that if that's the case, you don't have any chance, because you know, in usual steel welding, you have a 10-minute or time to just put these two flat plates together. Nobody can wait a week to put this flat plate together. But if there is some way to solve this kind of problem, then there is a big potential, I think. Well, anyway, let's go back to our original topic. Sorry. Okay, degree of similarity between product. Like a Hyundai Sonata, many identical product from one design. But in building or ship, it's a unique product. Okay? except apartment or something. Number of levels in the product structure, how can go deep into the product structure is also matter, or levels of the product structure from which the common interim product are shared between. Okay? Think of that for the construction and mass production. Okay, degree of similarity. Well, mass production part has much higher similarity. Number of levels in product structure. How many levels are there in construction and how many levels there in mass production? What do you think? Well, levels of product structure from each common interim product are shared also should be considered. So my question number 3 is, why might it be desirable to design a ship production system closer in nature to mass production than competitors' shipyard? Okay, the English wording is confusing, so let me reiterate it. Why mass production is good? And why other production system other than mass production are try to resemble mass production system? Okay, first of all, is mass production good? Production system wise? What do you think?
Mass production is good to reduce cost and time.
Okay, right. Think of it. If you're good at something, and if you're supposed to do again and again and again and again, it suddenly become an easy one. But the other case, you have to do something new. And then next, you have to do something another new. And every time you have to do something new, which is harder than mass production, right? All of this one is because of one. As you said, you know, we are doing this to make money, right? And there is something called economies of scale. In Korean, we call it 규모의 경제, right? What is economies of scale? Mr. Cho, what is economies of scale?
I don't know what.
But you know 규모의 경제 is, right? What is economies of scale? Yeah, you can say whatever you want. And I think by your look, you know what this is, right? Chain what? Okay. I can tell you're thinking in my word. Okay. If you produce same thing again and again and again, unit cost reduces, right? So the famous chart like that. This is number of units, which are cost per unit. Okay? If your number of unit increases, not the total cost per unit are behaving like that. That's the economies of scale. Right? But the chart is, if you go further, it is not asymptotically approaches to zero. At the very end, it goes up. If you're making too much units, then now you have to think about other things. Storage, maintenance, all other things. So unit cost increases back. Okay? But usually, most of these factories are playing around this area. Okay? So, if you look only this part, then the chart look like this. Okay? As production volume increases, unit cost decreases. That's the economies of scale. And we want to extract this one as much as possible. Right? Because the unit cost decreases, but we have a little problem. Our unit, product, part are not identical. We are producing all different parts because the ship is unique. So, okay. So, we are trying to utilizing this economies of scale in ship production system as well. But before then, let's think about why economies of scale exist. Okay? First of all, think of it. We need fixed cost. Fixed cost. Let's assume that you are the owner of Burger King. Over there, your rent, electricity, or something like that are just going out, regardless of the Burger King burger you sell, right? If you sell 100 Burger King, all this cost should be divided by them and should be applied to that unit, right? But if you sell millions of Burger King, then the rent and electronics and other things should be much less than that if you sell when you sell 100 burgers, right? So if you produce more, this kind of fixed cost can be divided more. So you can reduce the money, right? So fixed cost can be allocated over a greater number of products, okay, such as facility cost, tooling cost, and other things. Okay, the other thing is setup time between products actually prevent some very smooth production, but if you manufacture same thing over and over and over and again, you can reduce this kind of setup time. Okay, think of it. In previous class, I talked about the product variation, and in many automobile company, now it is just easy to make a variation, product variation in same line. So, for example, Daewoo Auto Company, one of their product is Damas. Do you know what Damas is? And do you know what Labo is? Labo is a pickup truck version of Damas. Damas is a minivan, van type, and Labo is a pickup truck. So it is actually possible because they share many parts between them. So in a single production line, you can make one Damas and then one Labo, one Damas, one Labo. It is possible. However, in order to do that, you have to change the drill bit or driver's head or something like that. So if you do Damas Labo, Damas Labo, Damas Labo, and then you have to change every bit. But if you make a Damas, 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 then Labo, 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 then your setup is also included, required only once. That is setup time. Okay? If you produce the same thing many times again, you can reduce the portion of setup time, also allocate it into the many other things. Right? Okay, work is more repetitive. Less skilled worker can do the job, right? At low wages. If a job is complex, you can hire less skilled worker. That's impossible. Also, work is more repetitive. Process learning and productivity improvements are easier. If you're doing same thing once and again, every time, you get skilled. You can just suddenly become 생활의 달인, okay? Because you do work again and again and again and again. It's more like a miracle or circus trick. But the reason is they are doing a lot repetitive way. Okay? Higher skill, then, the cost is lower. You can produce much faster or much efficiently, which also affect your unit cost. Okay. And more similar the product, the shorter the production time because of all this. If you reduce the time is really important. If you reduce time, it is not the time only. You reduce a lot more time heavily related with the other indirect cost, like electric power, salary, and other things. For example, to do some huge number of production, if you require 10 months, but if you increase the efficiency, you reduce the 4 months. So now only you require the 6 months to produce the same amount. 4 months of the rent, 4 months of the salary, 4 months of every other thing is just your saving. Okay? Time saving has a lot of effect to the cost saving. Okay. I got this data from some of the source. The x-axis means number of similarity between products produced in a single production system. 20% of similarity, 40%, 60%, 80%. And y-axis means production time relative to 100% standard production. Okay? Okay. What do you see? Do you see this y-axis is log scale? It's not linear scale. As the similarity between the production increases, your time required to produce is greatly reduced. See that, from 20% to 40%, from this number to that number. Okay? It's more than 1,000 times. From 40% to 60%, you only increase the 20% of similarity in the product. But from 38 to 3.4, 10 times of increase. I mean, 1/10 of the production time is required, which is huge, right? Why this thing happens? Because of these economies of scale. Okay, and our job in ship production systems, the trick is have to extract these economies of scale with non-identical part. How? The answer is we have to recognize the similarity between the intermediate product. In mass production system, every part are 100% identical. However, in our shipbuilding process, there is no 100% identical part. But if we try very hard, we can identify 80% similar part or 60% similar part. And as you know, if 100% is the best thing, but 80%, 60%, 40% is much, much, much better than 20%. So let's extract this kind of benefit. That's the key idea here. And group technology is all about this. Okay, have you read the paper distributed a week ago? What's the title? What's the title? Yes. It recognized the attribute between intermediate product. The important thing is attribute. Okay? Even though in mass production system, every part is same. You stamp one door panel is exactly same as the next door panel you're going to stamp. So all the length, dimension, process, same. In shipbuilding process, there is nothing like that. However, since we are producing a thing by applying manufacturing process or material handling process, let's focus on this attribute. For example, you are the workstation worker. In order to acquire this economies of scale, but you are very good at torch cutting, then if we gather all the part which requires the torch cutting, then even though the cutting length and cutting shape might be different, but as long as it is torch cutting, it is torch cutting. So you can extract those kind of effect, some effect of economies of scale. So that's why I said attribute. Recognize the attribute between intermediate product. Okay? And group similar intermediate product together and determine it as if there is enough volume to justify a development of a unique process lane or work cell. Okay? Can you see the lines here? So some parts go into the process A and then go to process E and G and go out of this system. And some parts go into the A and then process C. So anyway, since we are making a unique part, even though in a same shop, the flow of intermediate product is not well organized. It looks like this messy spaghetti. However, what they did is make 3 lanes. 2, 3. Can you see the difference of number of processes? In previous lane, there is 1, 2, 3, 4, 5, 6, 7. And next one is 9. The reason is, in order to streamline the material flow, they introduced another process A and another process D, 2 new processes. Well, it could be regarded as waste of money because we only read process A one time and process D one time. But it's a kind of trade-off analysis. By adding one more process A and one more process D, well, you have to put more money, but however, by streamlining all this intermediate product or extract the effect of economies of scale, you can save more. That's why people do like that, and it's a key concept in this group technology. Okay. In your paper, it is well explained with this figure. Okay, I think this is a lathe and milling machine, drilling machine, I don't know, and broaching machine and some machines. All machines, same machines are grouped into the same single cell. It is very good for the management purpose, planning purpose, because every same process are there. But material flow is a mess. But if you make this kind of, lower part of more complex cells, then your part only visit one cell. And your part can acquire some kind of economies of scale if you plan nicely. Okay, welcome back and let's continue. So, I think we've discussed about the group technology, what this is and why it is needed. And the next step is how we can use it. So, there are many other things, but most famous thing is to, like this three. This is not independent method. The similarity matrix and dendrogram and direct clustering algorithm, their key concepts are kind of interrelated to each other. The whole thing is all about how we can determine the level of similarity between this part. Okay. Typical chip intermediate product group or families, there are many things, but according to the ship production, the book written by Society of Naval Architects and Marine Engineers in United States, they can be categorized like that. Large parallel part from plate, this is our structural part. Large non-parallel part from plate, internal part from plate, part from structural shape and profile, built-up part from plate, built-up part from shapes and profile. They divided the little part, structural part like this, and I'd like to ask you to why, what's the reason, what's the reasoning behind this categorization? Think of it. And small internal sub-assemblies from plates and shapes, large stiffened flat plate, flat panels, large stiffened curved panels, large stiffened internal structures such as transverse web, large component from plates and shapes such as large foundation, and structural sub-blocks, also blocks such as flat, curved, special flat, special curved, and superstructure. The special means complex. Okay? And there are many outfitting parts like piping, HVAC. Anyone knows what this means? Heat, ventilation, air conditioning, right? It's all about that. To make that work, you need some, thing behind of this. And electronical panels like this and that, and valves and pipes, lighting fixture, shaft, and other things are all the outfitting parts. And outfitting assemblies, large and small machinery. For example, there is a condenser part, then this condenser part could be integrated with some structural foundation, can be an outfitted block or something like that. Large and small pipes assemblies and special thing. And outfitted block, in order to reduce the time required to stay inside of this building dock. Since building dock is the most precious resource in a shipyard, they wanted to reduce it, the usage time. And for that, they do something called pre-outfitting. Before you go into the building dock, you put all required outfitting material inside of this block and assemble together. Okay? And as I mentioned before, this outfit zone could be an intermediate product and also space on board the ship in which outfitting work is completed after erection and prior to system testing. Okay, outfitting zone should be treated as intermediate product, and it is really important. In many US shipyards, I heard many stories about it. You know, once you do the steel work and grinding and welding and, to the fixture, you have to weld it, and then everything is done. You grind it to remove the external excessive part and rust, and then you paint it, and that's all. But if you plan not nicely, and they happens to have another many interesting thing. You're working and your painting is done, but sometimes some parts begin to burn and your painting is ruined. Why? Because the other side of the wall is working is just welding. Okay? So have to consider this zone as an independent outfit, intermediate product and plan it. Okay? Okay, so this is one typical intermediate product flow through a shipyard. It's a Philadelphia Arcos yard inside of this United States. And this thickness of the red line means the volume of the throughput. Okay, so section, curved panel, outfitting shop, bulkhead shop, web shop, panel shop, everything is flow to finally to this building dock. Okay, this is the example of typical intermediate product flow. Unlike any other manufacturing system, we are dealing with very heavy and large intermediate product. Have you ever been to shipyard? How about you? Okay. Okay, good. You know what I'm talking about. It is not easy just to lift your part and, you need special equipment, cranes, transporter, and other things. Turning over is also a big deal, right? Moving is very expensive, so you have to plan it first, even though your material flow. Moving things is really expensive, so you have to minimize your moving path, right? Okay. Advantages. Well, economies of scale are gained. However, schedule is shortened because of this. Less skilled labor is required, greater possibility of automation. But there is disadvantages. You need exceptional planning. Planning becomes really complex. Okay? And control is really complex. And since this is all about identifying and recognizing the attribute similarity between the intermediate product, this thing should be considered in the level of product design. So in many shipyards, there are different departments. Production, design for production, 생산 설계, or something like that. Also, it requires a change in management focus from the final product to the efficient coordination of all production resources and intermediate product across all products. The thing is, it requires heavy and complex planning and implementation and control. And this is all about planning and control. So high management personnel should support all of these things. Without it, you cannot be successful. Okay. That's the end of the lecture material today, and I will give you this. As I mentioned before, there is 3 different things to do, and we will cover one by one in next class. But this is how we can categorize the group. You know, group technology means all about identifying similarity. The similar product should be grouped as a cell or group. That's why we call it group technology. And this one is one of that algorithm which can group the similar part systematically. And the title is DCA, Direct Clustering Algorithm. The thing is like that. If you go the first matrix here, upper left part, it is arranged like that. The row means part. So since we have 1, 2, 3, 4, 5, 6, 7, 8 rows, we have 8 different parts, right? And column means machine. So 1, 2, 3, 4, 5, 6, 7 column. So this means there are 7 machines. So it's like that. The part number 1, is required to be processed through machine number 1 and 3, right? So there are 2 access. And part number 2 are required to be processed through machine number 2 and 4. Part number 3, machine number 3. Part number 4, 1 and 3. Part number 5, machine 5, 6, 7. Part number 6 and 7. Part number 7 requires to be processed 5 and 7 and the like. Okay? And if you summarize the number of axes in each row and column, that's a row sum and column sum. Okay? And since this is matrix, you can easily change the columns together, the order of columns and order of row, right? Okay, changing the column together, does that changes the assignment between part and machine? What do you think? What if I exchanges column 5 and column 6 together? Then assignment of part and machine affected? No. You're grabbing everything and changing the location. Okay? Okay. For example, if I grab column number 7 and cut it, think like this is Microsoft Excel. If I select the column number 7 and cut, and if I insert this one in front of column number 1, okay, then does part and machine assignment changes? No. Even though I'm moving the location of column 7 into the other places, part number 5 should be processed through number 7, and part number 6, part number 7. These 3 parts are still should be processed in machine number 7, it is still there because only the changes is the location of this column number 7 now becomes the first column, right? Do you understand? Okay. Okay. Changing this column does not change any information on this matrix. Only the order of information. Okay? Changing row at the same time does not change any information on this matrix. Only it changes the order of the information. Okay? So you can freely change row and row and column. And this direct clustering algorithm is all about changing this thing. There is a special rules to follow, and this rule will be distributed at the end of this class. It's written very nicely on some research paper. So this is not a homework, but anyway, I strongly recommend you to do it at home. Okay. Once you do it, I will re-explain it from the start of the next class. And thank you.